All right, guys, so I've never done this with the headsets. Can everybody hear me okay? Because it's very discerning. I can't tell if you can hear me or not. All right, so what? Just air? All right. Well, hey, guys, we got a nice intimate group here, and I appreciate you guys coming in and let me share with you a little bit about building an AI command center. And this is more about a demo. So we're going to show you some pieces around what does it mean in the new era, and you guys, everybody's hearing it, we're all talking AI, and it's agentic this, agentic that, but what really matters, let's get it into practice. How do we actually put this into motion? How do we actually use this in the real world? And so, we'll skip that. For just real quick about KMS, those who may not know us, we're around 16, 17 years old. We got about 1,100 folks on our team. We are a very engineering-centric organization. So we're fairly light on our for lack of a better word, our overhead organizations, but we really invest heavily in our engineering components. So we are around the world. We got delivery centers and capabilities in the United States. We have 2 delivery centers in Mexico, 2 delivery centers in Vietnam, and we have another delivery center in Poland. Outstanding, bragging about the team a little bit, outstanding set of engineers, what they're able to do, what they're able to achieve. It's been, I've only joined about 10 months ago the company and been very impressed with the capabilities that our teams are able to bring. All right, now we're going to get to the rubber meets the road. Let's talk about a big number. $3 trillion. My brain has a hard time trying to comprehend a number that big. But what that number represents, that is what we lose on a global basis due to unplanned downtime of equipment and manufacturing. $3 trillion. A contributing factor to that is safety. And what we see, about 30% of the industrial accidents, these are severe and critical issues that not only impact the workers clearly, but they shut down factories when those accidents happen. Another sobering point about worker safety is 40% of those accidents happen in the first year of employment of those people. Clearly, we have a training and experience problem in manufacturing today. Now we start putting on our AI hat with this, and we also realize, oh, hey, we'll solve these problems with AI. Problem is, depends whose data you look at, 90 to 95% of all AI projects fail to make it into production. Very disappointing. And so there's methods and procedures how we address that. But you start taking all these in totality, this is how we get up to, among other factors, but this contributes to that $3 trillion problem. So what I want to share today is the attributes. What we're starting to look at is when we work with clients, and I'm going to speak now and kind of shift more about AI-centric approaches, what we are seeing today are way too many point solutions. So there's these little niches going out into manufacturing, into warehouses, and they're very narrow in their functions. What we yet have not done in manufacturing is to think about AI as a platform that is designed and built with multiple use cases, buy it once, change your workflow, and let it process the data. Because you think about, we're going to talk about mainly computer vision today. If I'm using computer vision, whether it's monitoring worker safety, whether it's looking at the knobs, dials, and gauges on a machine, or if it's looking at security, it's still processing data. What changes it is the model that I use to inference on it. But today, that would be 4 or 5 different point solutions we would deliver. We want to think about more holistically, a platform-oriented approach, and so what we start calling the AI Command Center, and we got 8 key attributes that we're looking at today to what makes this up. One of them is proactive worker safety. Using this data coming from AI to help support in your operational decision-making systems. Computer vision intelligence. We are now rapidly expanding. Now, we've been using computer vision in manufacturing for at least as long as I've been doing it, for over 40 years. Computer vision is not new. What is new is combining intelligence on the video. That's what's new. And it's beyond basic simple models. This is having the ability to have dynamic models. So we start fusing computer vision with better forms of inferencing, start bringing in autonomous operations agentically. We're really seeing changes in the computer vision space. And with a better computer vision system, now I can start applying that to asset protection. That same camera that's monitoring the behavior of employees, I can also use that to monitor a machine. I can use that same camera to monitor assets. It's just a different model. And now with the power of edge computing that we have available to us, we can really drive much more video processing at the edge, supporting multiple models, multiple use cases. And then we do have our predictive, we have our traditional AI, and we've been doing that for a while, where we use vibration analysis to make a failure prediction. That's part of it. We still, traditional AI, which is kind of funny to say, is still just as valuable as all the fancy agentic stuff. And then lastly, what we get with this, especially when we put platform-oriented stuff on the edge, now we start getting more of a real-time alerting components with that. So I'm not going to go into the details on the benefits, but at the end of the day, the reason we are advocating this is to obviously improve uptime in that factory, go after that $3 trillion problem, help keep our workers safe, and then improve the overall compliance and governance within the factory floor setting. Now, we're going to take that AI command center concept and we're going to explore one particular use case. And we're going to go more deeper into worker safety. How does this apply? What does that start to look like? And so there's two big elements that we can showcase, and we talk about it. And the first one is understanding and segmenting the floor, the factory floor of the warehouses. Not all areas are the same. Not all of them have the exact same risk profile. And just because you have an area doesn't mean everybody is allowed in that area. So some people may not be certified, they may not be trained. How do we detect that? And then the other one is object detection. So I can geofence these areas that we're working with on the floor, but now I got to be able to detect things. Not only do I have to detect it, I got to be able to classify it. So I got to be able to detect a human. I got to be able to detect, are you wearing a hat, gloves, your PPE? And you'll see that today. And then with that, I talked earlier a little bit about governance and compliance. How this helps in that area, that information that we're keeping through the computer vision now gets retained, and now we can use that for auditability and traceability purposes. A few more examples when we start looking at object detection. In the first area, and by the way, I'll say it at the end, I'll say it now, you can actually see this live working over at the SAS IoT area. My friend Sanjeev has it up and running over there, and you can go see yourself in that far left model that's called pose estimation. And so essentially, the power is turning a human into a stick figure. I turn you into a stick figure, now that's very powerful. Now I can measure angles. I can tell if your spine is leaning. I can tell if your knees are bending. So it becomes basic math and geometry once I convert you to a stick figure. But then we got to be able to look for those classifiers and look for non-compliance around, are you leaning over conveyor belts? Do you have your PPE? And then lastly, it's just not about the worker, it's also about the machines. So we can monitor the behavior of machines. We can tell, is a machine running? Now we may do that through a different sensor, through a PLC and picking that up, or we can see it running in the computer vision. But one of the key things is, and we know one of the number one leading of industrial accidents is failure to do lockout tagout. Somebody does not turn the machine, they turn it off, somebody else comes and turns back on, and there was a worker in there. and horrific things have happened. I mean, and it continues to happen. It's one of the number one leading causes. But now, that's just an object we can classify. If we know we're connected to the maintenance system, I know maintenance going on that machine, I can detect that. Now what I'm going to show you is a little bit of a demo, and I'm going to move back up here on the stage because there's certain parts of this demo that I want to stop, but I can't do it with this. So let me go up there. So the initial part of this video is around, we're just showing that in the modern factory today, we have a huge amount. A medium-sized factory can produce 5 petabytes of data.
Clear visibility into daily operations.
Sorry, I didn't want you. Were you guys coming through your headset, that audio? Really?
Built on your existing infrastructure.
Well, I'm going to let it play then. I didn't know that.
It delivers real-time intelligence.
That'll save me from talking.
Safety, asset protection,
but I will stop it
and
at a certain
operational
point.
Efficiency with computer vision technology. You don't need more sensors or more data. KMS embeds intelligence directly into the environments where operational decisions are made using the cameras you already have. Ready to see the command center in action? Let's dive into a worker safety use case. The KMS Worker Safety Solution is built upon your existing cameras to protect your workforce and prevent workplace injuries and fatalities. This is a camera feed from an active production floor. Watch what happens as this worker enters the frame.
Now I'm going to stop here. I just want to point out a couple items here, guys. You see that yellow area around front of the workbench. That's a geo-fenced area. And so that model now is saying, I'm only going to apply a rule when you step into that area. Over to the left, you see a red area. That becomes a prohibited space. Now, this is for illustration purposes. So we don't want anybody in that space over there. And then you see the pose estimation. So we're detecting a human, but look what we're starting to do though. We can tell that the human is wearing a vest. That's a different model to say, oh, do you have the right color vest to be in that area?
The system immediately detects a PPE violation, a missing hard hat, and creates an alert. The AI model isn't simply identifying a person. It is checking every required protective element for this specific zone, including the hard hat and a high visibility vest. The alert pings a supervisor, ranking the severity of the violation based on the location's custom rules, ensuring safety leaders can intervene before an incident occurs without chasing false positives. In this scenario, a worker proceeds to lean and lift in unsafe ways, opening themselves up to injury and risk. The worker safety solution captures his movement and tags the behavior when it becomes unsafe. Meanwhile, this worker's data is protected and anonymized according to PII standards. Data privacy increases workforce commitment to computer vision-enabled worker safety programs, leading to further prevention as workers buy into a proactive safety culture. Here, a worker has entered a restricted area. The system detects the breach and logs the event immediately. How is this zone defined? The geo-fence boundaries are fully configurable. Safety managers define them directly in the platform with no coding required. That means safety managers aren't just reacting, but designing a system unique to their environment and risk, ensuring that escalations are meaningful while keeping workers protected. When a violation occurs, the safety team sees an alerts dashboard with every incident time-stamped, geotagged, and categorized by violation type. The video feeds provide visual clarity to help safety leaders contextualize violations and leverage footage as an educational tool for further prevention. And safety managers can fully determine which cameras, zones, and unsafe behaviors are monitored. But worker safety is doing more than logging events. It provides a high-level view of safety performance across facilities, identifying key safety metrics and trends to help leaders prioritize interventions. Worker safety is just one facet of the industrial AI command center. The same computer vision technology that monitors worker safety can help protect your products, assets, and machines on the floor, as well as identify enhancements to operational efficiency. Bring AI into your operations. Get started with KMS Technology today.
And so a huge shout out to SAS. We're the core platform that we've worked with them to help create this and bring this to reality to help keep workers safe. But guys, here's the biggest takeaway about this is proactive technology. The vast majority of safety technology in industrial settings is reactive. Sprinklers, fire extinguishers, burglar alarms, think about all that. Those only trigger when the bad thing happened. This solution is proactive. It's capturing near misses. I like to think of it as a time machine. If we do not change our behaviors, you will kill somebody. But if we listen to the data and we see all the analytics, reintegrate that into our daily safety briefings, we can change the future before the accident happens. The analytics on this, we're capturing the near misses. That's why this is so compelling. It's not analyzing after somebody gets hurt. This is analyzing your behaviors before you get hurt, and we measure the risk index. So this is just one part of an expansion. We start thinking now we're going to start expanding to a total end-to-end safety component that we look beyond just that intermediate tactical piece I was showing, but now we start integrating all the different elements of OSHA reporting, your site surveys. Those of you that worked in factories and on the floor, when you do safety briefings, or safety audits, it's usually done by a human today. And at best, maybe people do it once a month, but typically it's once a quarter, and they fly around the world to go visit and do their safety audits. Using this approach, 7 days a week, 24 hours a day, it's continuous safety auditing. This is a radical change of how we can actually impact and keep people safe. So I wanted to thank you guys, appreciate it. We do have time for a few questions, I think just maybe a couple. Oh.
Thank you. Can you talk about the concerns about Big Brother and personal identification?
Yeah, thanks, Thomas. He was my straight man. I asked him to remind me that question. One of the items that comes up with this system is people say, gosh, you're monitoring everything I do. That's not true. Because this is a rule-based system of models, of policies and procedures. For instance, you are not supposed to lean over a conveyor belt. That's a policy. That's the only thing we're checking. All the other behaviors you're doing, we're not monitoring, we're not even capturing. So we're only monitoring those rules, those models that the client said, this is what's important to me. And by the way, almost all factories, people have already signed off on their policies, they agree to adhere to it. So that's why this really is not a Big Brother component. And plus, we can anonymize the people. This system is not designed to be punitive. What we really want it to be, work with the unions to say, let's keep the people safe. Everybody can win, the factory wins, they're keeping their people safe, they don't have unplanned downtime, addressing the $3 trillion problem. And then we've had some clients, because they had the system in place, they're able to renegotiate workman's comp insurance to get a discount. I did a talk a few weeks ago at the InsurTech conference up in Connecticut. That was a big point to them, and the carriers were like, well, wait a minute. If I know my customer who I just insured has a technology like this, and we're going to see a substantial reduction in risk, I'm going to give that guy a discount. So we actually, this is one of those technologies you get the proverbial triple win across the board. More questions? Yeah, Jason Hamp, what were you asking me? He didn't ask a question, I just put him on the spot.
Great to see you guys. So with a lot of this going, typical cameras based in the cloud, how are you handling the speed and feed of emergencies and handling that from a technology standpoint?
Good question. So when we think about that, in particularly those items when speed matters, latency counts, we do not advocate those, what you're seeing that example, doing that model inferencing in the cloud. Let's do the math, right? Got to capture the image, flow it through a system, get it up into the cloud, then I got to inference it. Is it bad or good? Send a message back down. Well, by the time you take processing and the inferencing, you're talking maybe 1,000 milliseconds. So, but if you want to detect a bad condition and send a signal to shut a machine off, time matters. So having a strong edge computing environment that supports AI, like our friends at Lenovo work with, one of our partners, that's why edge computing is so important. Plus, there is a practical benefit. You're not flooding your networks all the way up to your cloud doing all that. So you can keep it data localized, keep processing on the edge, and we're a big fan of that approach. In some cases it may make sense to do it in the cloud, but I'd only advocate that for like inspection when time is not the issue. All right, I'm getting the signal that I've exhausted my time today, guys. I really appreciate you coming in and let me babble a little bit, so thank you. All right, guys, thanks so much and enjoy the rest of the show. Thank you to SAS, too, for letting us be here today. Thank you, guys.